clearly?
Yes, ma'am.
Osmotic pressure. What is osmosis? What is osmosis? Here, participant is 35, but I have received 32 assignment. So I don't know. Fuad Hassan, are you there? Maybe your assignment will be counted as CD1. It's very important to submit the assignment. Fuad Hassan, are you there?
Ma'am, assalamu alaikum.
Have you submitted this assignment?
Ma'am, submit করিনি এখন।
Why?
Ma'am, আমি ম্যাথগুলো শেষ করিনি তাই সাবমিট করিনি।
So your submission time is over. So you don't want to submit.
ম্যাম, যদি এখন সাবমিট করা যায় সাবমিট করব, কিন্তু ম্যাম ম্যাথগুলো করতে পারতেছিলাম না আর কি, তাই সাবমিট করা হয়নি।
So what is osmosis? What is osmosis?
ম্যাম, দ্রবের কম ঘনত্বের এলাকা থেকে বেশি ঘনত্বের এলাকার দিকে ধাবিত হওয়ার প্রক্রিয়া।
Which in this amount? You are saying that from lower concentration to higher concentration solution, right?
Yes, ma'am.
Higher. Osmosis from lower concentration to higher concentration. Okay, your definition is কি বলো কি বলছিলে যে
ম্যাম, কম ঘনত্বের এলাকা থেকে বেশি ঘনত্বের এলাকার দিকে দ্রবের ধাবিত হওয়ার প্রক্রিয়া।
কিসের এলাকা? এলাকাটা কি বোঝাচ্ছে এখানে?
ম্যাম, মানে হচ্ছে
দ্রবণ সলিউশন।
Yes, ma'am.
Flow of solvent. Solvent.
Solution to higher concentrated solution.
Yes, ma'am.
Anyone else?
The flow of solvent from higher concentration to from lower concentration to higher concentration.
Low concentration, higher concentration, but which? What? Solution, solvent, solute?
Solvent.
Man, solvent.
So, lower concentrated solvent means what does it mean? If it is lower, if it has lower amount of solvent and higher amount of solution. Okay. Let's see here. Solution is a homogeneous mixture of solute and
Solvent.
solvent. And we know there are two types of solution on the basis of the amount of solute. If it is less, if it is significant in amount, high amount with respect to the solvent, then it is concentrated
Solution.
solution. So osmosis is the opposite of diffusion. Diffusion is the process where the solid particle shift from the higher concentrated area to the lower concentrated area. Okay, the solid particle. So osmosis is the opposite. Opposite means here solid particle will not be able to shift because in osmosis there is a membrane, semi-permeable membrane between the movement of both area. That means in case of osmosis, the difference is that a membrane is present. Semi-permeable means not completely permeable. One part is permeable or another part is not permeable. So here this semi-permeable. So what is semi-permeable membrane? A membrane which is permeable to the solvent only, not to the solute. This is a membrane, and the membrane core is very small. That's why the solute particle cannot go through the membrane, but the solvent can pass through this membrane. So we know solution is a mixture of solute and solvent. Right? So which area is concentrated and which is dilute?
Ma'am, left side is concentrated.
This one is concentrated. This one is
Dilute.
right. And here a semi-permeable membrane, and this is the solid particle, and this is the solvent particle. Okay. So definition, from the definition we know that semi-permeable membrane can only flow can only pass the this solvent particle from here or from here, from the both side. Okay, only the solvent particle, because here is semi semi-permeable membrane present. So it can be passed through this and it can pass through. But this cannot pass. Cannot pass. Okay. Is it clear?
Yes, ma'am.
So what is osmosis? I said it is the opposite of diffusion. Diffusion, in case of diffusion, there is no semi-permeable membrane and it's in a high concentrated area and molecule will shift to this area from the higher concentrated solution to the lower concentrated solution. Okay. But in osmosis, since the solute cannot go through the semi-permeable membrane, here osmosis is the process or the flow of the solvent through a semi-permeable membrane. Okay. From now you can say from here or from here also, but in both cases you have to mention clearly about this solution. It is dilute, it is concentrated. Okay. So here I am writing the definition. Two definitions. Both are correct. The flow of solvent from iron separated solution concentrated. Another thing, another definition is the flow of solvent from sorry, here it will be higher concentrated dilute solution.
Ma'am, can't hear you properly.
Can you see? Can you see? The flow of solvent from dilute solution to concentrated solution. The flow of solvent from higher okay. So higher concentrated solvent means dilute solution. Is it equal or not? Both definition. Understood? are equal because if the solute is small, the solvent is higher. If the solute is more, the solvent is lower. So you can select this definition. It is also opposite to the definition. Okay. So now, how it is a colligative property? Any guess or any idea?
ম্যাম একটু আরেকবার বলেন।
Why it is called osmotic? Why it is called colligative property? Osmotic pressure or osmosis. Okay, osmosis is the process by which the solvent flow from through a semi-permeable membrane. Okay, from dilute solution to the concentrated solution. And what is the osmotic pressure? To stop this flow, we have to give some pressure. And the pressure that is created by the flow of the solvent during the osmosis is called the osmotic pressure. That means osmotic pressure is the external pressure that is applied to the solution in order to stop the osmosis of the solvent that is separated by the semi-permeable membrane. Because if I give the solution like this solvent will move towards this and this level will be increased. And after some time, it will stop. When it is stopped, when we give some pressure, external pressure, then it will be stopped. And that pressure is called the osmotic pressure. So why osmotic pressure is called colligative property? How can you relate with the other three colligative properties? Any idea about this?
ইয়েস ম্যাম। ম্যাম এটা হচ্ছে গিয়ে নাম্বার অফ মোলের উপর নির্ভর করে পার লিটারে, কিন্তু এটা নেচারের উপর নির্ভর করে না, এই জন্য
So
এটাকে
it
কালিগেটিভ।
depends on the number of moles of the solute present
Yes,
in
ma'am.
the solvent. That's why if you increase the number of solutes, then the pressure will be increased. Okay, the pressure will be different. Whenever you will change the solute particle, number of particle in this solvent, it will change the pressure. For different types of concentrated solution, we will get different types of pressure because both solutions will not make same types of pressure. So in your reference book, there is a detailed experimental setup for understanding with the graphical, not graphical, with some figure or some schematic diagram to know about the osmotic pressure, how to determine, and what is the osmotic pressure you can find from there, from your book. It's just about the pressure which is applied from outside to stop the flow, because after some time when the maximum amount of solvent is already passed through the membrane, then you have to stop the osmosis process. And that by this process we actually, what we do, what is the application of this osmosis or osmotic pressure measurement? We
ম্যাম
can
এটা
know,
প্লান্টের ক্ষেত্রে দেখা যায়।
sorry, okay, there is also some application of measuring osmotic pressure because by this method we can determine the molar mass also. So now we'll see how we can identify or what is the application of the osmotic pressure, the four collective property. Before going to the application, another important application of osmosis is in case of kidney dialysis, this process is applied. You know what is dialysis?
Yes, ma'am.
You know about dialysis, so but you don't know about the method. In this case also, this osmosis process is applied. The impure particle is thrown out by the cellular membrane, but the pure blood particle is not permeable and they will remain in the blood. So first of all, from the patient, they took out all the liquid solution from the patient, okay, and they give it into the osmosis process, that means dialysis process, and their filtration happened. Filtration due to this membrane, the impure solvent particle. Impure solvent means impure particle which is harmful for body. They are actually separated from the membrane, and the pure blood will be separated from the impure part, and the blood is again give to the blood patient. Okay, that's the thing. And here reverse osmosis is occurred. Reverse osmosis is the opposite of osmosis. Okay, reverse osmosis means their solvent is passed, but their solute will be passed. Okay, so by some pressure. So you can find it also from your reference book if you want to know what is the process of dialysis, because you are going to be a biomedical engineer, so you should know about the dialysis process. Okay, so I have given you the slide in your classroom. There you can find a reference book. In your reference book also there is the example of kidney dialysis. So it's very important for you to know about the mechanism. Now, application of osmotic pressure. Application. So some laws are established for osmotic pressure, that is laws of osmotic pressure is proportional to the first law is osmotic pressure is proportional to the concentration. That means if I say that osmotic pressure, okay, for certain reasons, osmotic pressure is denoted by this sign, pi. It doesn't matter, okay? Then you can denote this by P also. But in our book, it is denoted by pi, as same as the this one. But for since it is osmotic pressure, that's why we have just denoted by pi. But it is not vapor pressure. Okay, that's why it is not similar. But the meaning is similar. The pressure is pressure means pressure, but it is osmotic pressure. It is vapor pressure. Okay. So osmotic pressure is denoted by P, and the first law is osmotic pressure is proportional to the concentration. C the concentration, right? At a fixed temperature when T is constant. know what is the expression for concentration. Concentration, if we express in molarity, what will be the concentration for 1 molar solution? N by V. Concentration expression is number of mole per liter, right?
Yes, ma'am.
So if I write here this one by proportional to C by V, sorry, N by V, is it okay?
Yes, ma'am.
So number 2 is osmotic pressure is proportional to the temperature. So why osmotic pressure is proportional to the concentration? Why? It's a colligative property. So it depends on the number of moles of the particle, right? So if I increase the concentration, the pressure will be increased. If I decrease the concentration, it will be decreased, right? Can you understand? সবাই কি বুঝতে পারছো? কেউ নেই নাকি ক্লাসে?
Yes, ma'am.
আমার কথা কি শুনতে পাচ্ছ না? তোমাদের কি এক্সাম আছে? So, osmotic pressure is the proportional
ম্যাম
concentration.
15 ওয়াইফাই এর সমস্যা দিচ্ছে।
Osmotic pressure is proportional to the temperature, because if we increase the temperature, the movement of the solvent will be increased, then the pressure will be increased. That means with increasing the temperature, the kinetic energy is increased, the velocity increased, the pressure, the osmotic pressure will be increased. Osmotic pressure is inversely proportional with the volume containing 1 mole of solid. That's the Vant't Hoff equation. Okay, Vant't Hoff equation tells the Gauss equation, the Gauss equation, Charles equation, and the Vant't Hoff. So osmotic pressure is inversely proportional to the volume which contains 1 mole of solid. That is actually this one, the last one.
Ma'am, can you repeat the number 3 question?
Sorry.
Ma'am, can you repeat the number 3 question?
Number 3 is the Vant't Hoff equation. That is, it is inversely proportional. The osmotic pressure of a dilute solution is inversely proportional to the volume that contains 1 mole of the solid and to the absolute temperature. So Vant't Hoff equation is this one. And by combining these two, we can get both of these. Actually, in your book, you will find the details. Now, if we combine all the equations, okay, we will get all the equation is all together, right? We find the final equation. Determination of molecular mass. By the loss of osmotic pressure, we know that number is proportional to the concentration, that means M by V, and proportional to temperature T. So now by V equal to here, suppose is like that. Okay. So this is the equation, and this K is equal to R. Experimentally found. What is R? What is R?
সার্বজনীন গ্যাস ধ্রুবক।
Very good. Universal gas constant. So experimentally it is found that the value of K is equal to the value of R. That's why we can replace pi V equal to N R. So now how can you measure the molar mass?
W by small m RT.
So this is the equation from where we can determine the molar mass of a solute by osmotic pressure. So now what is the method? Method is you have to take the solutes, you have to make some solution. One is dilute, another is concentrated, and you have to keep into a between the you have to keep into a container. So there should have a semi-permeable membrane like this, and you have to give some external pressure from this concentrated side, and you have to measure the pressure. Okay, if you can calculate the pressure, then you can find out this
মোলার মাস।
molar mass, because there only this pressure is not is unknown, right?
Yes, ma'am.
So if you know this pressure, temperature, which temperature you are taking, room temperature, and you know the volume of this container of the osmosis process, and you know the weight that you have taken, and the gas constant is the constant, so you know this one. So very easy process. You can measure the molar mass of the unknown solute from osmotic pressure. So that was our last topic of the colligative property, and we'll go to another topic. Another topic means another chapter. Next chapter, maybe I will start the chemical kinetics. Okay, so do you have any question on this class, today's topic? Is there any confusion?
No, ma'am.